Hello everyone, welcome back. Let's take a few notes here. We're going to continue on part 2 of our review today. Quiz for us, test is on Monday, so I'll be there bright and early on Monday morning if you have a bunch of questions for me. But let's just jump right in. I'm going to do a quick 2-minute review of kind of the problems we did yesterday in class. We did the first half of our practice guide. This is due completed by Monday, so if you'd like to take your copy home this weekend and study, that's great. If you'd like to turn in at the end of class, you can do that too. Just leave it with the sub and I'll check it over the weekend. But yeah, let's just continue on with our practice guide. We only have a few problems left. We have the second page, the back, which I think is significantly easier than the first page. I honestly think it is. So let's kind of jump right into it. And so we'll kind of review here. Number 1, remember I did not complete number 1. You have to do that one on your own where you have to find the first derivative of that. Just do the power rule, the power up front, subtract 1 off the power, that type of thing. It should be easy, short and simple. Number 2, we did this one yesterday where it was a chain rule using your trig functions. Just make sure that you understand like the derivatives I can provide you here or that I'll ask you to do are, either a power rule like you did in number 1, trig functions, sine, cosine, or tangent. It could be a logarithm, it could be an e problem, a natural number. So just be aware of the types of problems I could ask you to find a derivative of. I'm not going to ask you for anything like overly complicated, but it's going to be something that you should be able to handle that we've done quite a bit. Okay, number 3, we talked about, doing either left sum or right sum. You have to identify that for the picture, so it's going to be one or the other. You have to, tell me if it's an upper estimate or a lower estimate, so like overestimate or underestimate. N is the number of columns you have. Delta T is the gap between them, the distance between each column. And then obviously you have to find the approximate value. Now, we did not finish this one. You had to add up those columns. Again, you just have to be in the ballpark because obviously some people would estimate these columns different in heights. So you just have to be close. So that's kind of what we did there. We kind of estimated the first couple. So finish this one out. Make sure you figure out that final number and definitely show me work so I can see what numbers you're adding together. So I can see like, why did you come up with this number if it's like out of the boundary that I would consider as, close. Number 4, on this one, remember, you need to read the instructions. Now, up above, I said right post on this one, so you have to use from the right side going towards the left. So we're overestimating in a lot of these cases, and you do have to circle that. You can see that up above. I've circled the overestimate. That's a really bad circle. I didn't realize how bad that was. So we overestimated. So, and then what we did is we, just like the last problem, we found, the gaps between each of those columns, which was in this case is a 1, and we took it times the height. So we found the area of each, rectangle, and then we added those up. And you had to do this one on your own. You had to like finish this problem out. I wrote down most of the numbers, but some of you had different digits than me, which is fine. But just make sure you're finding the total, and this is the distance. That's what it's actually going to represent. So, all right. Yeah, let's move on to the next one. So these are the new ones today. So we're gonna find the first derivative, the integral of these, because we're finding the area under the curve. So you have to set up your integral. I have the lower and upper boundary provided to you, and you have to find the antiderivatives for these. So let me write the first problem down so we can set this up. So the first one, number 5, the integral from 0 to 6, x squared plus 1 with respect to x. Now, again, the area under the curve is called an integration. Right? It's an integral. It's an antiderivative. So antiderivative of this problem using the fundamental theorem of calc, where you add 1 to the power, and then whatever that power turns in, you have to divide by it. So my power, it will eventually, on that first variable, turn into a 3. So I have to divide by 3. That's the antiderivative of that. The antiderivative to 1, because it was 1x to the 0. That's what it originally was written as. I had 1 to the power rule. The power would turn into a 1 there on my x, so I have to divide by that. And now that's the full antiderivative. I could put a constant in the back, but I don't need to. And I'm going to evaluate this thing from 0 to 6. Again, that's that little bar in the back is just a notational thing to remind you, like, hey, you need to finish this, finish it. But yeah, plugging these numbers in, we have to subtract. So I'm going to plug in the upper boundary first. So the upper boundary with the 6 plugged in, this is 6 to the 3rd power divided by 3, plus 1 times 6 to the 1st power all over 1. So there's the upper boundary. And then we're going to subtract the lower boundary. Now the lower boundary is the easy one. If I plug in 0, to the third power 0 plus 0, so that the back is just 0. So it's really nice when the lower boundary is 0. There's just a lot of zeros, so it's kind of nice on this one. So eventually you'll have to finish this one out. You have to finish what those final numbers are. It could be a decimal. It's totally fine. You just have to, finish this parenthesis right there, that little bracket, and tell me that answer. So, but yeah, so kind of finish those out. Help each other out if you guys have any questions on that. But pretty much you just have to figure out the number, type it in your calculator, and finish it out. On number 5 on the test, or quiz, I would expect a pretty basic problem like that, where it's just a function, find the antiderivative, nothing like overly complicated. You just have to plug in the numbers and trust what digit you're getting. Number 6, trig function. You have to find the antiderivative to this. I think we've done one of these before, but the boundary is from 0 to pi over 2. That's 90 degrees in radians, but we're going to keep it in radians here. Don't change it to degrees. Don't do that. Your calculators can't do that type of stuff. For the normal numbers they can use radians. My graphing calculators can find the integrals of these. So we're doing cosine here of x dx. All right, so the antiderivative to this thing, the antiderivative to cosine is sine of x. Because if you think about it, if you were to take the derivative of sine, like go back, right, take the derivative of sine, it would turn into cosine. So this is the antiderivative, and we're going to evaluate it from 0 up to pi over 2. So that is the antiderivative to cosine. So you just have to think. The quick check is like whatever function you come up with, right? Just take the derivative, and would it get you back to the integral again? So like up above on that number 5, if I was looking at the part in blue right here, if I took the derivative of that thing, would it get me back to the part in green, x squared plus 1? And it would. So that's just how you can check if you did the antiderivative correctly. So now we have to evaluate this thing, right? I'm not even finished yet. So plugging these numbers in, sine of pi over 2 minus sine of 0. Now, if I just think about, what these numbers represent, like if I look at the wave graphs for sine, I can, figure out what the answers are. Most of you probably already know it. You probably already typed in your calculator, but just look at the sine graphs, right? Sine graph, the normal hash marks I'd hit would be 1 and -1. It would go out to 2 pi. This is pi over 2. So we're going to that first marker, right? We're going to that first marker. So sine starts at 0 and goes up. And then it would come back down, right? It would come back down over here. So I don't need to go that far. I just have to go up to pi over 2. So it looks like the sine of pi over 2 is 1. It's at its highest point. And the sine of 0, well, 0 is 0, right? That's where it starts. So 1 minus 0, and this would be just the number 1. There's your exact answer. And again, your calculators, graphing calculators, can actually find integrals, which is really kind of weird. We've never really talked about that you can actually handle this type of math. So in fact, let me just show you how you can type that in if you have a graphing calculator, if you're going into college. I think that's an important kind of concept that you need to be able to do. So let me show you your calculator here. All right. Okay. Now again, sorry, I have my calculator here from home. Sorry, I don't have my nice graphing calculator from school. I left it at home, and there's a crack on the screen. Don't leave them in the car during the winter. Okay, so here's how you do this. To type in integrals into your graphing calculator, you're going to go into your math button here, and this will give you a bunch of functions. So you can see there's a bunch of categories here. You can push your little over arrows to get to these categories. I'm just going to scroll down this list. This is like the main math column where you can do like fractions and decimals and other things. So I'm gonna scroll down here. Whoa, I clicked over by accident. All right, let's scroll down. And I'm going to go to this one. This is the function of integration. So you're going to do an integral of a function. So that's what this one is. You can do a derivative as well for number 8, but I'm going to do this one. So function of integration. And now what I'm going to do is I'm going to type in the function. Well, if you looked at the problem we were just doing, it was cosine of x. So I typed in cosine. I'm going to hit this little x key right here, and I'm going to close that parenthesis. So what you're typing in here is the function you're doing. So you could type in anything you want here. Then I have to hit the comma. So there is a comma button, And what you're going to type next, and this is something that you're teaching, Calc 1 or 2 or whatever you have in college, then what you type next is what variable you're taking respect of. So obviously for me, I'm doing X, so I have to type in X. The X key is right here, by the way, on most graphing calculators. This can represent any function you want. So it's just X for me. And then you're going to hit the comma again. So again, it was the function, whatever the function was, comma, what your variable was, comma, and now you're going to type in your lower boundary first. So I'm starting at 0, comma, and then you type your upper boundary. So my upper boundary is pi divided by 2. Again, the pi button on most graphing calculators here is right there. And divided by 2. And when you hit enter, it'll actually just tell you your answer. So the integral is 1. So it can do any function. So now if we did like the last one, for example, let's type that in. So let's see, math button. Let's go down to that function integration. We had what? X squared, x to the power of 2 plus 1. We hit the comma button. We type in my variable. We hit the comma. We type in my lower boundary on that one, which I don't even remember what it was. What was that problem again? It was 0 to 6. Okay, so not that. It's my Culligan bill, I guess. There we go. So my lower boundary was 0, comma, and then the 6. All right. So lower boundary, upper boundary, close the parenthesis off. You do have to close the parenthesis because, again, we had a parenthesis in the beginning. So you have to close that off and hit enter, and boom, there's your number. That's what we should have got in the last one. So kind of clever way to do these. But these graphing calculators can do a lot. I mean, this is an old calculator. I mean, my calculator that I'm using here is 20 years old. I had it when I was in school. All right. But there you go. So give you the hint of number 5 there. All right, let's jump right in. Let's do these next ones. Okay, so these are like those shortcuts we did in class, where we did the little in-class activity where you have to, add your functions together. You can do these as separate integrals. So the integral for the first one from a to b for f of x, that is right here. That number would be 8. So that's the function from a to b for f of x. The next one, we're doing the function of g of x, which is this one from a to b, which represents 2, and we're adding those together. Now, why we're adding is right here. They're telling you have to add these two together. And so this answer would be 10. That's all you have to do. You just have to look at, I give you those things up above. You just use those for your problem and tell me an answer. This would be a very similar problem that you'd see in like a math placement test or a Calc 1 test or Calc 2 test, where you're not allowed to use calculators. They just have these things above the test, and you have to do them. Pretty simple integrations. They're just testing if you know your properties or not. So I'm going to do the same thing. So they had a couple of these in the book. I just didn't assign them on the Google Classroom because they're kind of easy. You don't really need to do too much. Let's do the next one. So I had a couple questions on this one yesterday. At least one person asked it yesterday. We're doing the function squared, which kind of looks like this one up here, right? But then they put a c in front of it. So what you're going to do is this represents a constant. It's a constant number. It's not a variable. It's a constant. So I'm gonna factor that out. So you can always factor constants out of your integrals, right? If it's a digit, you can factor it out, which this represents a digit. Dx. All right. So this part right here, this part right there, would represent the 12. That's and then we have it times c that was out front. So your answer is just 12c. That's the exact answer. Now that's weird. C is a constant, whatever that number is. You just take it times 12. That's your answer. That's it. That's all you have to do on those. It looks like I didn't use the last one. Again, you're gonna have something very similar. I'm just looking at your book. I'll pick a couple of these out, and I'll put some down for 7 and 8, and you just have to find them. They're supposed to be quick, simple answers. It's not meant to be anything difficult. You just have to know what your properties are and how to use these. So, all right, there you go. I didn't even have to use that g of x squared. I didn't have that one on this one. All right, let's move on to the last two here. So the last two are related to each other. So these are ones we also did in class yesterday in our little activity, where you have to tell me an average for number 9, or on number 10 you have to use the same function as number 9, but tell me what the what the number was, the average again. So again, for averages, to find an average, you take the upper and lower boundary and you subtract them on the bottom of your fraction. That finds the spacing between the columns, and then you put that in front of your integral. So whatever your upper and lower boundary is, you subtract them, put them on the bottom of a fraction. And so this represents, this part right here represents the number 6. That's told you up above, it's right here. And we're gonna, take that times 1/3, because that's the number out front. It's like a constant out front. And so this ends up being just a 2, 6 divided by 3. And that's your answer. Like, that's the average of each of the columns for the area. That's the average of the area underneath that curve. The average is a 2 between each of the rectangles, if you add them, kind of like what we did in number 3 and 4 up above. All right, number 10, you're using the same function up above. Now, they warned you that this is an even function. This function up above, this one right here, is an even function. That means, when you look at the graph of it over the y-axis, whatever it's doing the same thing on this side. Right? It's a perfect mirror image. So that means, I think some of you already kind of figured out yesterday when you guys were talking about it, I heard some people discussing, was that the area is just doubled. That's what you do. The area on the right and left side of the y-axis is the exact same. So this functional value, so this is your first question, is, what is the value of, this function when you go from -3 up to +3? Because this function up here, if you see, it was going from 0 to 3, was 6. So from -3 to +3, this would be doubled. So the area that your integral, this thing would represent 6 times 2. You double it, which is 12. Okay, so there's the first part. We answered it. The area is 12 because it's the right and left side of the y-axis is the same area. So you just go 6 plus 6, really. Now, we have to find the average again. So, again, we have to take the upper and lower boundary and subtract them. So 3 minus a -3. And we're going to put that in front of my integral from -3 to +3 dx. So this is 1/6. My area is 12. Or the area under the curve from -3 to +3. We just found that a little bit ago. And so this represents 2. Well, duh. Think about it just for a few seconds. The average of number 9 was 2. Right? That was just the right side. If this is a perfectly symmetrical graph, right, the right and left side are the exact same picture, the average would be the same number. They're symmetrical. The average isn't going to change any. It's still the same number. So that's why it's coming out to be 2 again. So yeah, just kind of think about those common sense. I'll give you a function. Basically what this is doing is testing whether you know how to find an average using that little number, that little leading number out front. But it's also testing whether you understand even and odd functions. So whether you know how that works. So, all right, but there you go. Expect the same number of questions on your test. Expect, the back page is usually the easier. I'm not joking, it's easy. The back page is meant to be quick and simple and to the point. The first page, you have to do a lot of work. Take your time on this, finish it up. There's a couple problems I didn't do on the first page. You have to, clean it up a little bit. Make sure you double check each question, make sure you answered each question correctly. You can turn this in if you want, if you don't want to lose it over the weekend, but if you want to take home and study, that's fine. It's due Monday. Quiz is Monday and be ready to go. All right. See you guys.